Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 7.1 entitled Graphing Linear Systems. And today we're going to solve a system of linear equations by using the graphing method. And a system of equations is just when you have two or more linear equations that have the same variable. So you might have an equation that's x plus 2y equals 3, and then you'll have another equation like negative 4x minus 5y equals 6, and they'll want you to graph both of those equations on the same coordinate plane and see where they intersect. And where they intersect, that's the solution. So a solution of a linear system is the ordered pair that makes each equation in the linear system a true statement. So that means when I take this ordered pair, this AB or XY, whatever you want to call it, and I plug it back into the first equation and the second equation, I'll get a true statement for both of them. Okay? So what we're going to do today when we're solving our linear systems is we're going to solve each equation for y if it's not already solved for y. Sometimes they give you an equation that's already solved for. And then we're going to graph them using our slope and our y-intercept. And then we want to see where the lines cross. Now, most of the time the lines cross. I think for all of the problems we're going to practice today, they do cross. But there are a couple special cases that we'll talk about in the future where the lines don't cross. And we'll talk about what that means when we get there. Okay, now for example 1, this is just a conceptual question. They want us to check and see if the ordered pair 1, 3 is a solution for each of the equations in this system of equations. So what we're going to do, this is kind of like what we were saying, what I was saying in the definition of the solution of a linear system. When you take that ordered pair and you substitute it into each equation, if you get a true statement for each equation, then that ordered pair is a solution for the whole system. So remember, in your ordered pair you have an x and then you have a y. So I'm going to take this first equation, x plus y equals 4, and I'm going to substitute this ordered pair into it. So I'll have 1 plus 3 equals 4. And 1 plus 3 is 4. 4 equals 4. So yes, that's a solution to the first equation. Then I'm going to take my second equation, the one that's on the bottom equation, and I'm going to substitute 1, 3 in there as well. So 2 times 1 plus 3 equals 5. So that's 2 plus 3. And 2 plus 3 is 5. And 5 equals 5. So yes, that is a solution for the system because it is a solution for each equation. So that means if I solved the top equation for y and graphed it, and solved the bottom equation for y and graphed it, these lines would cross or touch or intersect at this ordered pair at 1, 3. So that's what we're going to be finding. And here's our two examples that we're going to do to practice that. So for part A, I have a system, and the nice thing about the system of equations is that they're always written with these squiggly brackets. The x's are going to be lined up, the y's are going to be lined up, and then the numbers are going to be lined up. So for this one, when we go through our steps, we are going to have to solve both of these equations for y first. And this is why we spent a whole chapter practicing solving an equation for y, and why we spent a whole other chapter graphing, because you need those two skills in order to do this system of equations. So for my first equation here, I'll have the x minus y equals negative 2. I'm going to subtract the x over to the other side. So I get negative y equals negative x minus 2. Remember, I want to put the x first so that it's in slope-intercept form. Y equals mx plus b, remember. And then I have to divide by the negative 1. So y equals x plus 2. That's my first equation. I'm going to put a little blue dot by it, and then I'll change colors here. And I'll do the other one in red. I'll put a little red dot by this one. So all I'm going to do is I'm going to rework this equation so that it's solved for y, so that it's easier to graph. So again, I'm going to subtract the x over, y equals negative x minus 4. Remember, you're not going to be able to combine these terms together. They're not like terms. And we want to just write the x term first and then the number so that it's in slope-intercept form. Okay, so now I have my equations in graphable form. So I can look at each of these equations and I can say, okay, my slope is whatever, and my intercept is whatever, and I can graph that. So for my blue equation here, this first equation, if I look at this, there's a little 1 in front of the x. So my slope is going to be 1. My intercept, oh boy. Okay, so my slope, let's try this again. At the time, my slope is going to be 1, and my intercept is going to be 0, 2. So that's the point I'm going to start at when I'm graphing. I start at 0, 2, and then I'm going to go up 1 and over 1. Now I don't know where the other line is going to go. I don't know where it's going to cross. So when I'm graphing these, I want to make as many points as possible to go across my graph. And I want to be precise because I need to know where this line could possibly intersect with the other line. So you definitely want to have graph paper when you're doing these. Okay, now for my red equation, I'm going to have a slope of -1 and an intercept of -4. So I'm going to start at -4, and I'm going to go down 1 over 1. Now I could keep going this way, but I'm not going to cross the blue line if I keep going down this way. So I'm going to go back to -4, and instead of going down 1 and to the right 1, I'm going to go up 1 and to the left 1. I'm going to backtrack. And then I'll be able to see that right there is where my lines intersect. So that's going to be my solution. That point where they cross is really important. That's going to be my solution. Put it in green here. So that ordered pair right there, that's what I need. And that is -1, 2, 3, -1. So -3, -1 is my solution. Now that means if I took -1 and -3 and plugged them back into both of these equations, I would get a true statement. So if my x is -3 and my y is a -1, -3 minus a -1 is +1. -3 plus 1 is 2. And here -3 plus a -1, that's a -4. Okay, so when you graph and you get your solution, you can double check it. So we're going to do this process again now for part B. Part B is just a little more challenging, maybe. Okay, for this first equation, I'll do that in purple. We have the 3x plus y equals 11. So now I'm going to subtract the 3x to get the y by itself. So y equals -3x plus 11. Okay, so there my slope, I'll write it over here. My slope is going to be -3, and my intercept is going to be 0, 11. So we'll be slightly off the graph there to start that one, but that's okay. The other equation, let me do that in green. I also have to solve this for y. So I'm going to subtract the x. Now remember, the negative is going to stay within 2y. Now I have -x plus 6. And I have to divide everything by a -2. And remember, even though there's not a number in front of this x, remember there's a -1 there. So 1 divided by 2 is going to be 1/2 x. And then -3. 6 divided by the -2 is -3. So my slope for that equation is going to be 1/2. And my intercept is going to be -3. Okay, so let me go back to the purple line. I'll graph that now. 0, 11 would be right about there. And then my slope is -3. So 1, 2, 3, and then over to the right 1. Down 3, and to the right 1. I'm going to keep doing that until I make my way across the graph. And then when I connect them, I want to be precise here. You can use a ruler, you can use the edge of a notebook, you can use your ID. And then the other line is going to be 0, -3 for my intercept, and then 1/2. So I go up 1 and over 2. Up 1 and over 2. There we go. There's where the lines cross. So that's going to be my solution. And it looks like right there, that's going to be 1, 2, 3, 4, -1. That is my solution. And again, if I substituted the 4 and the -1 in for x and y, I should get -11 for solution. So 3 times 4 would be 12, plus a -1, that would be 11. And then 4, let's see, -2 times a -1 is +2, so 4 plus 2 is 6. Okay, so this is what we're going to be focusing on today, is graphing and finding where those lines cross. The ordered pair is the solution, though. Don't forget that. That's what we're trying to find, the ordered pair. Sometimes students graph them and then they don't write down the ordered pair. Okay, now we do have one last problem. It's a word problem. And this one we're not going to graph. We're going to see if we can do this algebraically. Okay. It says you're an ecologist. You're studying the population of 2 types of fish in a lake. Use the information in the table to predict when the population of the 2 types of fish will be the same. Now that's the key word right there. Will be the same. If things are the same, that means that they are equal. So we want to see when A will equal B. Okay. Now fish A has a current population of 5,750, but it loses 250 fish per year. I say loses because it's negative, so that population is going down. So for population A, I'm starting with 5,750, but I'm going to have to subtract 250 per year, so times x for however many years this goes on. And then fish B has a smaller population to start, but they're growing. They're gaining 500 per year. So I'm going to substitute in the 3,500 plus the 500 per year, so 500 times x. So there's my linear equation that I'll be able to solve now. Now we could graph these as well. We could graph y equals -250x plus 5,750. But I don't want to make a graph that has a y-intercept of 5,750 or 3,500. Okay, that would be a really big graph. So we would, if we were going to graph this, we would probably use a graphing calculator to graph this one. But we can solve this algebraically now. We know how to do this. We know how to get all the x's on one side and all the numbers on the other. So I'm going to add the 250x over to the other side because it's smaller. And we like to pick on the small amount, move it over to the other side. I'll have 5750 equals 9,500 plus 750x. And then I'll get the numbers over to the other side. So I'm going to subtract the 3,500. So 5750 minus 3,500, that's going to be 2250 equals 750x. And now just finish solving for x, I'm going to divide by 750. So So x equals 3. And that would be 3 years. So if we wanted to write that in a complete sentence, we would say, in 3 years, the fish populations will be the same. Okay, so this problem is still dealing with a system of equations. You still have two equations in slope-intercept form that you're setting equal to each other and then solving algebraically. So this is a little bit of a preview of what's going to be coming up tomorrow as well. We're going to do more algebraic work tomorrow with systems of equations instead of doing so much graphing. So for today, your homework is to practice these problems. Remember, you also have exit problems to do, so don't forget about that. And if you have any questions, come on in and see me before school.